In this video, we will prove that the square root of 2 is irrational. So we'll start by recalling our definitions. Remember that rational numbers, which we denote with the symbol q, are all numbers of the form a over b, where a and b are integers, and the denominator b is not 0, because otherwise that would make it undefined. Irrational numbers are real numbers that are not rational. So we've seen examples of those like pi, or square root of 2, or e. We've yet to actually prove any of these things are irrational. That can be very tough in general, but for something like square root of 2, there's a nice technique to show it's irrational. We'll actually do that in this video. So here's a strategy tip. If I'm trying to show something is irrational, we need to show that it is not, let's put that in red, it is not rational. And we've seen this before, but that to show a quantity is not something, we typically try a proof by contradiction. Okay, so we're recalling the strategy tip that we've now seen a couple of times. So if I'm going to prove this is irrational, I'm going to assume, for the sake of contradiction, that it's rational. So let's assume that square root of 2 is an element of q. That's just me saying that it is a rational number. So what does that mean if it's rational? It means I can write it in this form, a over b. Okay, so that means square root of 2 equals a over b for some a and b, which are integers, so they are elements of z, and the denominator has to not be equal to 0. Okay, so assuming that it's rational, for the sake of contradiction, let me write a very concrete thing down. So, okay, I'm going to assume one other thing about this, which is I can do anytime I have a fraction. Suppose that my a over b, my fraction, is written in lowest terms. So lowest terms means, like, if I had a fraction like, 5, well, let's actually do like 6 over 8. That can be simplified further. I can divide the top and the bottom by 2 to get 3 over 4. And that would be in lowest terms. So I can do this with any fraction of integers. I can put it in lowest terms. So it's fine for me to suppose that my fraction is written in lowest terms. Because if it's not, well, we just simplify it so it is. Okay. So now I'm going to start doing some manipulations. And let's square both sides to get rid of the square root. So if I take my square root of 2 and my a over b and I square both sides, so square the left, I got to square the right. That implies I'll get 2 equals a squared over b squared. And if I multiply both sides by b squared, this implies that a squared equals 2 times b squared. So just so this is aligned better, let's just move this down a little bit. Ooh, let's move this down a little bit. Okay. So this means, let me end the sentence actually here. What I now have is that a squared is 2 times something. But that something, the b squared, is an integer. And that means a squared is even. A squared is even because b squared is an integer. So a squared is 2 times an integer. Okay, so nice. So let's use that fact. If a squared is even, we've seen this thing before, that a squared is even if and only if a is even. Right, that's a corollary that we've seen before. A squared is even if and only if a is even. So because in our problem a squared is even, that means in our problem, that means a has to be even. Okay, nice. So let's use the definition of what that means. Because a is even, that means there exists k, which is an integer, such that a is equal to 2 times k. Okay. All right, so now what I'm going to do is I'm going to take this and let's substitute it in the equation that we already have. So let's substitute it in. So I'm going to substitute my a equals 2k into our equation a squared equals 2b squared. So we're continuing to do our manipulations. And just for the sake of consistency, I'm trying to keep all my manipulations in orange. All right, so subbing it in, what I get is 2k getting squared is equal to 2 times b squared. And if I simplify the left, I get 4 times k to the 2 equals 2b squared. And I could divide both sides by 2 to get 2k squared equals b squared. Okay, so I'm going to align this better. So let's just move this down a smidge. Ooh. Okay. But wait, that means b squared is 2 times an integer, which means b squared is even. It's even because this k squared thing is an integer. Since k squared is an integer. I'm just multiplying 2 integers together to get that. So it's an integer. So, well, because b squared is even, we can use this corollary from earlier that, well, that implies that b is also even. So at this point, it feels like we're kind of going in circles a little bit, right? We got a is even. Now I got b is even. You know, where are we going to go with this? Well, at this point, we actually have a contradiction of this lowest terms thing from earlier. So let's point that out. However, a and b being even, both being even, contradicts. This contradicts the assumption that a over b is in lowest terms. Is in lowest terms. Okay, and that means our assumption that the square root of 2 was rational is incorrect. And if that's incorrect, that means square root of 2 is actually irrational, like we wanted. So we're ready to write that conclusion. So as a result, square root of 2 is indeed irrational. And that's how we prove it.